So students, here we have a discrete ungrouped data and we need to calculate the quartile deviation. Now one thing which is very clear that the number of observation is replaced by the sum of frequency. So the total number of frequency is 150. And for Q1 we know now the formula is the same, just the number of observation is replaced by the sum of frequencies. Sum of frequencies plus 1 divided by 4 term. So for that term we need to find out the cumulative frequency. For saving the time I have already calculated the cumulative frequency and I have taught you previously that how the cumulative frequency can be calculated. It is the falling of the frequency in the next class, adding that, then falling that frequency into the next class, adding that two frequencies, that falling, adding, and we know that the quartile can be calculated by these formulas. So now let's put the values in that formula and find out the first quartile. So the total number of frequencies is 115 plus 1 divided by 4 term. So we will get the 29th term, or we can say the value. Now let's see with the help of the cumulative frequency corresponding to the values that where is the 29th term will be covered. So the 29th term will be covered in that particular section, 29th term. So the Q1 is 2. Now same we will do for the Q3. Then how the Q3 can be calculated by the same formula, just the formula is changed by multiplying the 3 into Q1. So now we will get the term. Now let's see where that term will be covered. Just below that particular section it will be covered here. Is 3. Now we will going to calculate the quartile deviation by Q3 minus Q1 divided by 2. So the Q3 is 3 minus 2 divided by 2 and we will get the quartile deviation with 0.5. So this is how the quartile deviation can be calculated when the data is the discrete data. Now let's see then when the data is the continuous group data, then how we will calculate the quartile deviation. So students, we are going to learn that how can we calculate the quartile deviation when the data is the continuous frequency distribution group data. So for saving the time, I've already calculated the class boundary because there is the gap between the intervals and we need to eliminate that gap, and because we want the data in the continuous form. So I've calculated the class boundary and cumulative frequency because for the corresponding to that cumulative frequency we will get the class. So we know that the formula for the quartile, first quartile, is L plus H upon F into sum of F divided by 4 minus C, where L is the lowest class limit, H is the width of the classes, F is the particular frequency of that particular class, sum of F is the total number of frequencies, and the cumulative frequency of that particular cumulative frequency of the class we will get. Now first we need to locate the class from where we will get the values to put in that particular formula. So for that we will take that section just like previously we were doing. (187.5). Now with the help of that term, we will find out the class. Now let's see where that term will be covered. So it will be covered in that second class of this particular data. Now let's highlight that. 187.5 term. So we will get the class, which is, we have the class 50 to 54. Now let's put all those values in that particular formula. The lowest class limit is 50 plus the width is 5 divided by the particular frequency of that class is 272. 750 divided by 4 minus the cumulative frequency is 335. 334. 51.81. 51.81. Now with the help of the same method we will find out the Q3. Yes, we have added the 3 into sum of f divided by 4. So we will get the value which is the 562.5 value of term. So we will locate that into the particular frequency distribution table. It will be covered in that particular section. 562.5 term. Now we are going to put all those values in that particular formula and we will get the Q3. So with the help of the same method we have calculated the Q3 which is 58.14. Now with the help of the following formula for the quartile deviation, we will get the quartile deviation Q3 minus Q1 divided by 2, which is 3.165. So student, this is how the quartile deviation can be calculated in different scenarios by different formulas. Hopefully this is helpful for all the students which are new to statistics, and if you have learned something new, then I request you to please like that video, share that video to other students, and don't forget to subscribe my channel and hit the bell icon for the notification of new videos related to statistics and probability. In the next video, we are going to learn about the interquartile deviation, then how can we calculate that with the help of the graph, when we have a graph and we need to calculate that. Till then, Allah Hafiz.